In this video, I am going to discuss about how to represent a function or function representation. But just to remind you about the definition of function, function is a mapping between two sets where each item in the first set maps to only one item in the second. And just a quick example: A, B, C, D, E, F. A maps to E, B maps to D, C maps to F. Here is a simple example of mapping between two sets. So this is a valid function. A maps to one item, B maps to one item, and C maps to one item in the second set. The first set we call it domain, and the second set we call it range. Okay. Now, how do you represent function? Function could be represented in many different ways. Here is an example. I just represented function as a mapping. But in real world, a function is many times a mathematical formula or mathematical equation. So let's start off with an example. Let's say y is equal to f of x is equal to 2x. This is a function. Okay. By the way, please note that this f of x is a definition of, it's a notation for function. It's saying that we are dealing with a function where the variable x is the independent variable and y is the dependent variable. So I just kind of introduced two new terms, independent and dependent variables. Independent variables are coming from the domain and dependent variables are coming from the range. And this f of x, it's by the way, please don't think that it is f multiplied by x. It's read f of x. It's just one unit, one thing. So when you write f of x, don't ever think that you are multiplying f by x. It's just saying that we are dealing with a function that depends on the variable x, and normally we represent it by y. Okay, we write y is equal to f of x. And what is f of x? In this particular case, f of x is 2x. Many times you will write y is equal to 2x, implicitly understanding that it is f of x, which says that the variable y depends on the variable x. X is the independent variable, y is the dependent variable. And independent variable values comes from the domain, dependent variable values comes from the range. Now, if we consider this function, we can basically express it as an equation. So I just gave you a second way of representing function, which is by formula or equation. First one was by a mapping, second one by a formula representation or equation representation. And then third one, I could give you a table. So this is my x and this is my y. Okay. So let me just label these things to help you see things better. So this is my number 1, this is my number 2, and here is my number 3. Third way of representing function. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 1, y is negative. Oops, sorry, I made a mistake. It's 2x, right? So it should be if x is 0, y is 0. If x is 1, y is 1 times 2, which is 2. If x is negative 1, is going to be negative 1 times 2, which is negative 2, and so on and so forth. You can pick x is equal to 5, y is going to be 5 times 2, which is 10, and so on and so forth. So this is a tabular representation. Tabular representation. Okay. Now, yet there is another representation I could think of, which is this. I'll call it number 4. Pair. Oops, let me use a different color. It's a pair. Function could be thought of as a pair of numbers, which is typically represented by x, comma, y. X represents the independent variable, y represents the dependent variable. So if we look at this table, by the way, this table, okay, we can just represent these numbers as 0, comma 0. Then 1, comma 2, negative 1, comma negative 2, then 5, comma 10. You see, the same concept, same thing could be represented in this way. Okay, it's a pair. xy pair. So a function could be represented as xy pair. Remember, here the order does matter. So the convention is to put the independent variable first and the dependent variable second. So you always put the x first and then you put the y. Now another way to represent function, which will be this graph. So we have an xy relationship. So this is my x and this is my y. So if I graph y is equal to 2x, so y is equal to 2x, what it is going to be? It's going to be a straight line through the origin. See, this is a graphical representation of the function. So I just quickly showed you 5 different ways of representing functions. So these are the most common ones, and I hope you are familiar with these things. So let me summarize again. What did we do in this video? We talked about function representation. In the process, we talked about function definition. Remember, function is a mapping between two sets, while each item in the first set maps to only one item in the second. Okay? And also, function could be thought of as input-output. That means for each input, there is an output, only one output. Okay? And inputs come from domain and outputs come from range. Now, so we could represent functions as a mapping. We could represent functions as a formula. We could represent function as a table. We could represent function as a pair of points, xy pair, and we could represent function as a graph. So all these ways you can represent a function.